Welcome back. We're going to be talking a little bit more about exponents. This is the retake video, so we're going to go a little bit quicker through some of the beginning topics to make sure we can give you some tips on how to do fractions and decimals a little bit faster. As a review, 3 is the base, 4 is the exponent or the power. Therefore, in this problem, the power tells us how many 3's we multiply together. So we are going to multiply 4 3's, which would give us 9. And we can multiply them together to get 81. And we can multiply out of order like this because of the commutative property. Let's do a few quick examples. 2 to the third power would be 2 times 2 times 2, 3 times. That would be 4 times 2, which is 8. 5 cubed is equal to 5 times 5 times 5, 3 times. 5 times 5 is 25. 25 times 5, I think of this one as 5 quarters is equal to $1.25. So 25 cents times 5 would be $1.25. 4 to the fourth power, we're getting a little bit bigger here. 4 times 4 times 4 times 4 again. This is 16. This is 16. 16 times 16, that one I can't do in my head. Is 256. And last but not least is 8 squared, or 8 to the second power, which is 64. Once again, a 0th power, which we talked about in the last video. Anything raised to the 0 is not 0, and everything raised to the 0th power is equal to 1, except for 0 raised to the 0th power, which is impossible. So you probably won't see that until you get a little bit older. But that means that 3 raised to the 0th power is 1. 5 raised to the 0th power is 1. Even fractions like 1/2 raised to the 0th power is 1. And like a decimal, like 25/100ths raised to the 0th power is also 1. Fractions work just like whole numbers do. You are taking the base, which is a third, and you are multiplying it times the top a certain number of times. So in this case, it'd be 1/3 times 1/3 times 1/3, which ends up being 1/27. Another way to think of this problem is you can take the exponent and kind of distribute it to each number on the inside. So you end up getting 1 cubed over 3 cubed, which ends up being the exact same thing we got. So you can think about it both ways. For the problem on the bottom, we're doing 1/9 times 1/9 times 1/9 again. 1 times 1 times 1 is 1. 9 times 9 is 81. 81 times 9, I can't do in my head, so let's write that one on the side. Well, 9 times 8 is 72, so it makes this 729 for the bottom. Just like we did above, you could do 1 cubed and 9 cubed as your fractions, or as your fraction, and then multiply each of them out, and you end up getting the exact same thing we got before. And now, as promised, I wanted to show you a shortcut for doing these decimal problems. So for the first one, 5/100ths to the third power means that we're doing 5/100ths times 5/100ths times 5/100ths. And if I wanted to multiply this out, it's actually going to take a long time because I'd have to do 5/100ths times 5/100ths. I'd get that answer, and I'd take that times 5/100ths again. It ends up getting pretty messy. Another way to think of it is because for every multiplication problem in a decimal, you're adding the number of digits together, or digits behind the decimal point together. So in this problem, we have a total of 6 digits behind the decimal point. So I'm going to do 1, 2, 3, 4, 5, 6 digits behind the decimal point total. Then I take the significant digits of 5 times 5 times 5, and I multiply them together. We did that earlier in the video and got 125. So here's the shortcut. If I take 125 and I write it in the back of my decimal points, now I simply add in zeros for the remainder, and wouldn't you know, I get my right answer. You can always do it the long way, but this short way of counting the number of decimal places behind, or number of digits behind the decimal place, can save you a ton of time. So for the problem on the bottom, I wanted to use an example where we'd save a ton of time, because 4 thousandths times 4 thousandths times 4 thousandths times 4 thousandths is going to take forever. But I see 3 digits behind the decimal place in each of these spots, which means we need 12 digits behind the decimal place in our answer. All right, so now we take the significant digits of 4, and I do 4 times 4 times 4 times 4, which we did in the video already and got 256, which I then put at the back of my long decimal chain, and I fill in the rest with zeros, and I'm done. And that's one that the correct name for this decimal is pretty tricky, so I'm not going to make you say that one out loud. But hopefully that gave you a little bit of information on exponents, exponents with decimals, fractions, and whole numbers. As always, if you have any questions, please let me know.